Welcome to my session on eliminating bug classes using browser security features. Yeah, I hope you are as excited as I am about this topic. The purpose of this talk is for you to get new ideas, maybe learn about new concepts that you have not seen before, and maybe you can think about how you can apply them in your own workspace, especially the scale deploying such browser security features across a big landscape of applications, about multiple products that you own or multiple servers. And yeah, let's kick this off. We are going to talk about common web security flaws. I will show you the latest version of the OWASP proactive controls. I will show you a case study from Google, which was like I found this when I saw this research paper from them about security signals or web signals. I was so impressed that I wanted to bring this to my own organization and also apply this concept. And that's why I want to show you their concept, how they implemented this. And then finally, we will talk about some of those new modern browser security features for defense and dev. And like I said, I was so there's also I also have a 4-hour workshop version of this. So it's now very difficult to put everything into a 20-minute presentation, but I tried, and I hope you are going to like it. But of course, there's much to consider, especially rolling it out on a scale and so on. Yeah, why are we having this talk is mainly because I thought those topics, they haven't surfaced that much yet, like moving to a strict content security policy, but also other very modern browser security features which are still in development and also not yet supported by all major browsers. But it's very nice to have a look at this development and think about how you can already deploy them because they already provide very great value. And yeah, I wanted to bring more attention to those type of features and generally moving from having this reactive mindset to this proactive mindset. So a few words about myself. My name is Javan. I'm based in Germany. I work in the application security team at Sage. On the side, I'm lecturing secure coding. I'm passionate about web security, Raspberry Pi stuff, and home automation. I used to do software development, web and mobile. Then I became a pen tester and a consulting type of role, and now I joined Sage 5 years ago in an application security team, and now I'm focusing again in scaling and building stuff again. So there was some change in our mindset, how we approach application security as well. So before we start, let's take a look at the common web security flaws that we have. I took here, there are many top 10 lists that you can use, but let's take one top 10, which is the HackerOne top 10 vulnerabilities of the most reported and most rewarded vulnerabilities in their platform. And you can see number 1 is still cross-site scripting vulnerabilities. This is a little bit insane because it's a very old vulnerability, and we still don't really manage to fix it properly, and it still surfaces. And I also cycled some other type of vulnerabilities which are also covered with some of the controls that we are looking at and during this talk. So maybe let's take a look. Why is cross-site scripting still one of the most rewarded or found vulnerabilities? So many organizations, I think first, many organizations still struggle to implement a strict content security policy, a strict one, but also challenging to find all vulnerable spots for where they can do input validation and output encoding and so on. And second, attackers still find very innovative ways to bypass those defenses. And this, for me, this is a proof that we need those layered defenses, multiple defenses, and we will look at those and look at those browser security features which we can use. So even if you forgot to do a proper output encoding, that you still have like a content security policy, a strict one, which then blocks that cross-site scripting attack. So why do those vulnerabilities still persist? And let's before we move on. So first, we have very complex systems, lots of connected APIs, many applications. I think, I don't know, I need to just continue talking and then it's not, okay, that's good. So second, we have a very reactive mindset about our vulnerabilities. Like we fix occurrences, like a new issue that pops in from a bug bounty report or from a pen test report, and we only patch those symptoms. And we have maybe third, we have a limited automation, so it's hard to scale those security practices across a landscape of many applications or services. So I compare this like this whack-a-mole game that we are playing. So we have this constant emergence of new issues. We are very reactive, not proactive, and with that we have a never-ending cycle. And it became very stressful, resource-intensive, and with that, of course, we don't have time to properly look at the root causes and also no time to implement those proactive controls. So yeah. Then I wanted to show you the last version of the OWASP proactive controls, which is a top 10 list of very good practices. And of course, number one, number two, it's all about input validation, output encoding. Those usual practices that we already know and that we already apply every time we have a vulnerability coming in a pen test report or from any type of static source tool scanner. So, but I wanted to show you the number 8, which got added in the last version last year, number 8, which is about leverage browser security features. So we now see there's indeed something happening, which we should take a deeper look during this talk. And for me, this also means we need a defense in depth, and this is basically how we scale the vulnerability elimination, because we won't be able to patch or all the input validation or output encoding. Maybe we won't be able, and that's why they still surface. So we need this defense in depth, and here are just a few examples how you start doing that. Like the first one here, session hardening. You add a HTTP only flag to your cookie so that a JavaScript, if you have a cross-site script vulnerability, cannot access that token or that key from the cookie. So there are multiple defense in depth mechanisms. And the last one, finally, the browser enforced policy. This is about having a strict content security policy. Just an example for some of the defense in depth mechanisms. Now I wanted to show you that research I was talking about initially from Google, and you should really look that up and download this paper and read it. It's very, very good. It's called Security Signal, and but I'm going to show you what they actually did in this paper, because I use it as a blueprint, as a template to now work similar as they approached it. And I mean, it's from Google. They kind of own Chrome, and they worked on those standards. They worked on this content security policy version 3. They worked on those new security headers, which we will talk about, like Sec-Fetch-Metadata and some other security headers. So it's, of course, they also have now a very nice approach of not only adopting it at a certain scale, but also measuring the adoption at a certain scale. And that was what I found interesting if you work in a large enterprise. So let's take a look at a challenge. The challenge is, of course, adopting to those security features in a very large-scale web ecosystem. And how they approach this, the solution is quite easy, because most times you anyway already have a reverse proxy, like an Nginx in front of everything, or even if you use a commercial version like Cloudflare, you basically already have your man in the middle. You can inspect there, and you can put up some rules, first, not only setting those security headers, but also checking if they are existent, and that you can apply that as in one place for everything, basically. And that's basically where this works. So it's like a proxy level, and they use some synthetic signals. That's how they call it. So it's about making it measurable. So actually, they check on each service. They check, for example, is there content security policy existent? Is there CSRF protection existent? They check, are the security fetch metadata header existent? And I will talk about those and explain how they work a little bit later. But also, of course, interesting, do I have a legacy application? Do I have a modern framework? Maybe the modern framework is already doing the output encoding by default. So like, it's giving us very good indications, which we could inspect on a proxy level. And finally, so this is a screenshot from that paper, but I found it very useful to show you how you can make it measurable. This is a scorecard which you would have for every service. And here they show you, okay, we have a trusted type header set, we have some other headers defined, and this is just the outcome of those metrics. Unfortunately, there's no commercial product. This is not open source. We have to build this ourselves right now, so vendors, please listen. But it's a very good, innovative idea. Let's talk about those browser security features which I just mentioned during those slides. But before I talk about those, I wanted to show you a cross-site reaches forgery vulnerability. For those who don't know, it's like, imagine you're browsing the web and suddenly there's a request made on another website that you're also already logged in, and then action is performed, and you can see that image tag. This is then example how something like that happens, because browsers tend to send cookies automatically with each request if you don't have settings like same site attribute set to those cookies. So this is an attack, can look like this code snippet as well. But now there's something new, which is those security fetch metadata headers. And with those headers, they got introduced in 2021 to all major browsers, so you can start using them. It's another defense in depth, how you can protect about cross-site reaches forgeries attacks. Because now you can start validating server-side on your Nginx proxy level, where did this request came from. To make this more clear, this example, this is how a curl request looks like if you send it in your command to example.com. You just have this bunch of headers being added to the curl request. But let's compare this request, how it looks like if you open example.com in your browser and you open DevTools, Network Inspector. And then you can see those Sec-Fetch headers, they give you very detailed and very good information about where this request came from, also the target origin and the current origin, like is it a cross-site request basically. So it basically tells you already, okay, this is cross-site request. So what we now just need to do is verifying that header and just look into the value as a defense in depth. And this is very easy to deploy. You can just go in your Nginx and write that rule. I think this is how the rule can look like that you need to code. So very powerful. Has someone already noticed those headers when you look in burp in your proxy and so notice? But did you know what they do? Yeah, so that's the good thing. I already skipped something. Which slide are we on? Okay, this slide. Now talking about again how they work. Imagine you have the site.example and there's some JavaScript sending a fetch request to site.example. So you can see the headers telling you same origin. But if you have evil.example and you have a request to site.example, it tells you cross-site, and that's how you can then block this cross-site reaches forgery, basically. So this works really good at scale. Now let's talk about content security policy. You can see here an example of a content security policy. Who has a content security policy deployed for his applications? I see a lot of hands. Who thinks you have a secure one? You think so? That's the difference, isn't it? Moving to a strict content security policy, because this really is going to eliminate lots of the cross-site scripting vulnerabilities. And I want to take the example of Google again here, because they have a strict content security policy for Gmail. And they increased the bug bounty for Gmail to $50,000 just for a cross-site scripting vulnerability, because they didn't see any cross-site scripting vulnerability report for over 1 year. So this shows you how effective this can be if you move to a strict content security policy. But it really is a difficult balance, how you can deploy it, that's, I guess, as a product security engineer, that's often the biggest challenge. How can I deploy the CSP? How can I have the right balance between marketing and all that type of content that is hosted on my website and without breaking functionality? But here is really the focus that you start with a report-only content security policy, that you can then monitor your violations that you have and then move iteratively to a more secure content security policy. Here I created like 5 steps how you can do this. Like I said, you start with a report-only policy. This can be a very strict one, but then you generate some violations which you monitor, and then you basically add those violations, or you have to refactor some code. And with the latest versions of content security policies, you also have a script dynamic directive, which allows you to be also it's just got easier to deal with all those Google marketing ads, those type of frameworks which you unfortunately have to embed to some of the websites. So it's got easier, and you need this mix between reporting and iterating and moving to a strict content security policy. And of course, there will be some automation this you need, and it really depends on what application you're dealing with. Is it a legacy app, or is it a modern front end with SPA? Because you could also automatically some of the directives or the rules within your content security policy during the build, and for example, calculating hashes and nonces, or adding nonces to your scripts that you have in the website. Then finally, another modern browser security feature which I wanted to show you is trust types. Has anyone heard about trust types? I already saw. That's good. So it's part of content security policy. You can see here the rule, how you can enable it. And it's actually very powerful, for example, against DOM-based cross-site scripting vulnerabilities. And this is very helpful if you work with legacy applications where you have maybe lots of DOM-based cross-site scripting vulnerabilities, and you don't want to refactor everything, because trust types works like a client-side sanitizer, or you can utilize it to a client-side sanitizer. Unfortunately, it's not yet supported in Firefox, but they're working on it right now. But you already can use a polyfill to import it to Firefox, so it would work there if you use the polyfill. To show you the concept, of course, you have those risky APIs like inner HTML, outer HTML, evil. Those are the most times the source of the DOM-based cross-site scripting vulnerability. But now you can start writing a wrapper around them, or like you can introduce a policy where you then use maybe a secure API like DOM Purify, where you remove all malicious content from the JavaScript, and that way you can eliminate also DOM-based cross-site scripting, and it's easier to fix your legacy stuff, basically just using that. Of course, maybe you don't need it if you already are on a very modern framework, but most of us aren't, and this is about deploying it everywhere. Here's an example before, where you have like the vulnerable example, you use inner HTML, but now you introduce that policy, which is the wrapper, which uses the DOM Purify library, and then you have a safe function. So that way it's easier to refactor, and if you set up some policies. But this can be also used in different situations as well. So it's interesting that there's now like a client-side sanitizer happening in the browser. I wanted to finish this presentation with a quote from Frederick Braun from Mozilla. So he was saying, web security is increasingly an opt-in approach, leaving developers with both the opportunity and the responsibility to protect their applications. So it's everything which I just showed you is about opting in, because we can't break the web. They can't put something out there which changes the standards. And I think thinking about cross-site scripting vulnerability, one of the oldest vulnerabilities we have in the web, maybe it's a design flaw from the beginning, but we can't change, we can't break the web. So some takeaways. Let's shift from reactive patching to this proactive security. Think about how you can implement it in your organization, because it can be a real game changer, especially if you have one application that has one cross-site scripting vulnerability. In my experience, depending on the time and effort you put in, you will be finding more cross-site scripting vulnerabilities in the same application. So having a content security policy is very great. And adopting to those secure by default principles, those headers, and recognize the power of those browser-led security features. And with automation, you can also scale. You saw the example how Google did this with the Nginx proxy. And let's start doing this. Commit to the bug class elimination. Yeah, thank you for listening. Hope you enjoyed. Good. Are there any questions? It's fine. I'm also there. Like, yeah, good.
You have like tools to craft CSP because they are hard to craft. You have like
no, I can repeat it. Yeah, I have tools to craft CSP. Yes, it's very difficult. It's a challenge. I think because it's also not a big topic for people. Like there is an add-on from Mozilla from April. It's called Mozilla Laboratory. It's only for Firefox, but this helps you generating a CSP, but then like crafting a CSP during automation maybe. So actually you need your own scripts in your CI/CD, maybe that calculate hashes or add those nonces. So I only have custom built stuff for that approach, but there's some stuff, but it's difficult. And also another very good tool which will help you is the Google CSP evaluator, which is also giving you some feedback about the security and the safety of your CSP. Good. Yes? You wrote it? Ah, you wrote that. Amazing. Good. Yeah, you wrote it. Okay, amazing. It's good. Good. I will be there also in the hallway if you have any questions. So it's good.